We have this habit of talking about AI like it's the single monolithic thing, just marching steadily towards one big final goal. But what if that's just completely wrong? Today, we're going to dig into a really fascinating idea that pretty much flips that whole concept on its head. Get ready for the great AI split.
So let's just jump right in with the big question. Is AI really on this one single track, heading for some kind of super smart general intelligence? Or is something a lot weirder going on? Is it actually splitting apart, branching off, and evolving into totally different kinds of minds right under our noses?
Well, the thinking behind this whole explainer is that, it's definitely the second one. The core idea is that we are living through a massive split, a real divergence in the evolutionary tree of AI. It's not about one mind getting smarter, it's about the birth of many different minds. And the easiest way to get your head around this split is by looking at two new classes of AI that are popping up. On one side, you've got the Analyst. This is an AI built for pure, verifiable truth. And on the other side, the Artist, an AI built for wild creativity. And listen, these aren't just slightly different versions of the same thing. They are built on fundamentally different blueprints with totally opposite goals.
Okay, so let's get into what makes these two kinds of AI minds tick. We're going to start with the one that probably feels more familiar, the one we think of for serious work and research, the Analyst.
The whole reason an analyst agent even exists is for one thing: convergence. Its entire purpose, right down to the architecture, is to take this huge, messy universe of information and just collapse it down into one single, provable fact. It's all about killing uncertainty and finding the ground truth.
The best way to picture it, think of the analyst as a super meticulous librarian, or a really rigorous scientist. Its entire mind is like a perfectly organized library where a hallucination isn't a funny quirk, it's a catastrophic system failure. This thing is engineered from the ground up for one thing and one thing only: truth.
So how does it pull this off? Well, these agents run on a super strict plan and solve playbook. Let's take a look at a research model called Dr. Tulu. First up, there's global planning. It looks at the big question and breaks it into tiny, manageable steps. Then, it moves to local execution, where it just methodically plows through each of those little steps. And then, and this is the absolute key, it does a verification pass. It actually goes back and checks its own work against the source data to self-correct. The whole process is basically designed to squeeze every last drop of hallucination out of the system.
And because it's so specialized, this architecture can do something pretty incredible. That same agent, Dr. Tulu, can handle a really complex research task for a mind-bogglingly low price. We're talking less than a penny.
And this right here really shows you the sheer power of specialization. You see, to do a similar job, a big general-purpose model might cost you, say, $1.80. But this specialized analyst, it does it for a tiny fraction of a cent. That's not just better, that is a total game changer for efficiency.
All right, now let's flip the coin and look at the other side of this great split. If the analyst is all about converging on one answer, the artist is all about, you guessed it, divergence. Its architectural purpose is the complete opposite. It's designed to wander out into the weird, long tail of probability to discover new things and to spark creativity. It's not about finding what is, it's about inventing what could be.
And the metaphor for this one is totally different. The artist AI isn't a quiet library. No way. It's more like a chaotic lab, or maybe a living, breathing theater. It's actually built to manage entropy, to take what the analyst calls a hallucination and reframe it as controlled imagination. It is literally engineered for a kind of beautiful, productive chaos.
And its mind works in a completely different way too. Take the Generative Agents project from Stanford and Google as an example. These artist AIs use what's called a memory stream. So instead of just remembering the last thing you said, they pull up memories based on a mix of how recent they are, how important they are, and how relevant they are. And that lets them build these really believable, long-term personalities that actually seem to learn and grow, just like a character in a great story.
Okay, so we've got these two very different kinds of AI minds, which, of course, leads to the next big question. How in the world do we talk to them? How do we actually control them? And that brings us to the language of control.
The single most important thing to get here is that prompt engineering isn't what it used to be. It's not this fuzzy, conversational art form where you're just trying to find the magic words anymore. Nope, it's grown up. It is now a serious, rigorous technical discipline. It's much more about engineering and architecture than just having a chat.
And at the heart of this new discipline is the system prompt. Honestly, the best way to think about this is to stop seeing it as just another instruction. The system prompt is the foundational operating system for an AI agent. It's the core configuration file that lays out its entire identity, its tools, its rules, all before you, the user, have even typed a single word.
So, if a prompt is an operating system, that means it has to have an architecture, right? So let's crack one open. Let's really deconstruct the anatomy of what a professional, gold standard system prompt looks like on the inside.
A really solid system prompt isn't just one big paragraph of text. It's a modular system with 5 key parts. First, you have identity and role. Who is this AI supposed to be? Second, capabilities and tools. What can it actually do? Third, instructions and boundaries. These are the core rules of the game and its safety rails. Fourth is formatting. How should the output look? And finally, number 5, fallback and safety. What does it do if it gets stuck or confused? Each one of these pieces is a lever that controls a very specific part of the AI's behavior.
Now, here is a super important insight for anyone who's actually trying to build with this stuff. While that 5-part logical structure is pretty much universal, the physical syntax, the actual words and symbols you use to write it, is incredibly specific to each model. What works perfectly for one AI can be completely ignored or even misunderstood by another. What this really means is that we have to learn to speak different AI dialects. And to see what I mean, let's look at a side-by-side comparison of how this syntax is totally different between 2 of the biggest platforms out there.
I mean, the differences here are just crystal clear. OpenAI's models, like GPT-4, they respond really well to Markdown and just plain English reminders, literally telling it things like, be persistent. But Anthropic's Claude models? They've been specifically fine-tuned to pay super close attention to XML tags. For Claude, putting instructions inside those tags isn't just for making it look nice, it's one of the main ways you actually control its behavior. We're not kidding. It's like learning 2 different languages for 2 very different minds.
Okay, let's pull back and look at the big picture again. We've seen that AI is splitting into these different mind types, right? And we're having to create specialized languages just to control them. So what does this all mean for how we're going to interact with this tech in the future?
Well, it points to a really fundamental shift in what skills are going to matter most. See, it's not just about who's the best at talking to a machine anymore. The future really belongs to the people who can design the systems that let machines understand what we want and then do it, reliably and accurately every single time.
You can actually see this as an evolution of the job itself. We're moving away from the prompt engineer, who's really focused on just talking to machines, and toward the AI interaction architect. This is a much more strategic role. It's about designing the core systems, those operating systems we talked about, that define how a machine even begins to understand us in the first place.
And that brings us to the final thought I want to leave you with. We're clearly moving past a world where we just use AI. We are now in a world where we are actively designing its cognitive frameworks. So the question we all have to start asking ourselves is this: as we become the architects of AI interaction, what kind of future, and maybe more importantly, what kind of minds are we actually building?